All right, we're going to pick up with belt and pulley systems. I know what you're thinking. You're thinking, Mr. Kitro, that last video was really long. Hopefully this one is not as long. And you're right, this will not be as long as the last time. This will be a little bit shorter. But what we want to do is talk about belt and pulley systems and also sprocket and chain systems and see how do those relate and how do they compare to our gear ratios. And you're going to find there's a lot of similarity and a little bit of differences. And so as far as similarities go, we're going to have all the same sorts of equations. Now you notice this doesn't say gear ratio because these are not gears. So when we look at a belt and pulley system, we are still going to be talking about the same sort of ratios, but we can't call it a gear ratio because it's not a gear. But that's okay. We're still going to work out the same way. The only thing that is missing besides calling it a gear ratio is because we're dealing with belt and pulley systems, the pulleys do not have teeth. They are just going to be wheels, basically. They've got a little groove in there for the belt to sit down in there, but basically they're just circles, they're just wheels. And so we do not have teeth to count. So it takes away one of our options. So instead of having tooth count as an option, we can't do the number of teeth of the output over number of teeth of the input like we did with the gears because we don't have any teeth. So that takes out one of our options. So we only really have three things to look at. We have the diameters of the two pulleys that we're looking at, and we also have the angular speed and we have the torque. And so that's what we're going to be looking at is those things. Now, one thing that's kind of interesting here is that the belt itself, from a linear distance, linear speed perspective, is going to be traveling the same speed everywhere. So that is going to be the same everywhere. That is why we can do all these calculations because everything's tied together by that belt. Now, if you've ever seen a belt driven system before or maybe heard one, if you get too much torque and not enough grip, we don't have the proper tensioning on it, if it's a little bit too slack, you will have the belt slip. So we do not always have a perfect system with a belt and pulley system. You do have to pay attention to the tensioning and making sure the belt is tensioned properly. But if it is, and we're going to assume it is, we're going to assume the system is set up correctly and works the way it's supposed to, then we are going to have where we're transferring all of that torque and all that power from one pulley to the other. And that's kind of the assumption here, is that we're doing that. Now, granted, we talked about this with mechanical advantage, that there's always going to be a little bit of lost force and effort as we go through the system just because of friction and things like that. That definitely happens here too. When you look at gears, you look at belt and pulley systems, and you look at chain and sprocket systems, there is a lot of lost force between friction and slipping and things like that, although the slipping is primarily just the belts. We're not really worried about that stuff right now. All we are really worried about is just assuming it's a perfect system. How do we calculate the ratio, and how do we find like angular speeds? How do we find torque? All those sorts of things. Okay. So when we're looking at our belt and pulley system, because we do not have teeth, we are down one option. So we only really have is these three. So it's going to be a pair out of this set. So either we're going to be looking at diameters, we can talk about angular speeds, or we can talk about torque. Those are our only options. And what we should be finding is that they're going to be in the same ratios as they were with the gear systems. And so if we take a look at these two, they don't tell, oh yeah, they do. Okay, so this red one is our input, blue one is our output. So we're going to look at what is the diameter of the output. Well, the diameter they're telling us this pulley is a 6-inch diameter. This one is a 2-inch diameter. So if we look at the ratio between the diameters, we're going to get 6/2. So there we go. And if we look at the ratio between the angular speeds, now again, this is the same formula as we used with the gears, so it's still going to be input over output for the angular speed, just like it was with the gears. It's going to be input, which is 30 RPM, over the output, which is 10 RPM. So we're going to get 30/10, and we notice ratio is still 3:1, 3:1. And then we look at our torques, and they're telling us here that our output torque is 55 foot-pounds, input torque is 18 1/3. And this is one of those where you're just going to have to take our word for it a little bit. or do the math. But if you divide 55 divided by 18 and a third, you're going to find that that is also 3 to 1. So we're going to have the same ratio between all of these different ratios between different measurement types. So whether it's diameter measurements or it's angular speed measurements or it's torque measurements, that ratio will stay the same as we move through this belt system. So what does that mean? Well, it just means that now we are going to be able to do the same sort of calculations we did with the gears. We can calculate the overall ratio and figure out, okay, if I have this much input torque, what output torque will I get if these are my diameters? Or I can say, hey, I really want my output torque to be this much. Here's my input torque. How big should my pulleys be? You can do those sorts of calculations. One thing that's a little bit different about belt and pulley system, and we'll see the same thing with chain and sprocket systems, is that because these are not directly meshed, they're being moved, in this case, by the belt or chain. We do chain and sprocket. What's going to happen direction-wise is if this one goes clockwise, this one is also going to go clockwise. And that's going to be true about anything that is inside of the belt. So anything inside the belt is going to travel the same direction. So we're not getting that reversal of direction like we did with the gears. So these two are going to turn the same way. Now you can cause one to turn the other way if you put it on the outside. You see that with like an idler pulley where we use it for tensioning. So you might have a pulley out here on the outside that's just there to kind of keep the tension. That one, if it's on the outside, will turn the opposite direction. So you can still cause a belt and pulley system to have a pulley turn the opposite direction, but the only way you can have that happen is if that pulley is on the outside of the belt. So think of it as like a rubber band or something. If it's on the inside of that loop, inside of the loop, everything's going to turn the same way. If it's on the outside of the loop, no matter how convoluted that loop gets, and if you look in your car again and take a look at the serpentine belt that drives all of your accessories like your air conditioning, air conditioner compressor or your alternator, those sorts of things, your water pump, that belt that drives all those things has lots and lots of twists and turns as it moves through that your engine. But what's going to happen is anything that's on the inside of that belt is going to be turning the same direction. But some of those pulleys will be on the inside, some of them will actually be on the outside. So some will turn clockwise, some will turn counterclockwise, just depending on whether they are on the inside or the outside. So that's kind of the difference. Okay. Sprocket and chain and a belt and pulley are really the same, except now we're back to having teeth. So we look at our sprocket and our chain system. We do have teeth, and that means that we are able to go back and do our tooth count as part of our finding our ratio. Now, it's still not a gear ratio in the strictest sense because they're not gears, although they kind of look like gears. The big difference between a sprocket and chain type of sprocket and a gear is just the shape of the tooth. If you notice, and you can't see it real well, but in that little animation they have up there, those teeth on the sprocket are a little different shape than what we saw with the gears on the earlier pictures, and they're spaced quite a bit further apart. And that's just because they need to mesh with the chain, and the chain has a very specific geometry. There's lots of round axles that it is trying to align with. And so the spacing around that sprocket is going to line up with the spacing of the chain. And so they have to have a big opening for where the chain is going to kind of lock in and sit on that sprocket. So does it look like a gear? A little bit, but it doesn't have the same tooth shape as a gear. And usually it's a little pointier, a little further spaced out, a little pointier than what you see with a regular gear. So when you look in the VEX stuff, you're going to see we have VEX sprockets as well as VEX gears, and they do have different shapes and they look a little different. So, but all the same things are going to be true. So we're going to have those same set of equations. Here they are. Again, not a gear ratio, so we're not going to see the GR for gear ratio, but realistically, it's the same set of equations. And so that's why, even though we can't call it the gear ratio, we're doing the same calculations. But now we do have the ability to count teeth. So we can go and count how many teeth are on each sprocket and use that to calculate the ratio between these. So we say, okay, well, how many teeth are on this one? How many teeth are on this one? output over input, we could calculate that ratio. We can go back and measure diameters, which they've given us here. So we can do with diameters. We can do with our angular speeds. And again, angular speed, we always do in over out for the angular speed. Or we could do it with our torques. So all those things, we'll just click through these here pretty quick. And we can say, okay, well, all these ratios should be the same. That's what we're saying. They're all equal. So if we look at the number of output teeth, which we can't really tell from this picture, I don't know if you actually counted those little dashes, if it'd really be 22 or not. But that says 22. This one's saying 11. Take their word for it because they don't have any way for us to figure that out exactly. That is our ratio. It's a 2-to-1 ratio. If we do the diameters, it's 3 inches as our output, 1.5 is our input, 2-to-1 ratio. If we look at our input speed and our output speed, so again, for the angular velocity, we do in over out. So we're going to do 90 RPM divided by 45 RPM. Again, 2-to-1 ratio. And then if we look at our torques, 120 divided by 60, it's going to be a 2-to-1 ratio. So this is going to be, again, not a gear ratio, but basically equivalent to a gear ratio of 2-to-1. So I'm going to have twice as much output torque as I have input torque, but I'm going to have half as much speed. So this one's going to move half as fast, but will have twice the torque as my input because of the ratio, just like it was with the gear ratio, same idea. But this is kind of a combination between the two because it has the teeth like a gear, as far as we can use teeth to figure out a ratio, but it's going to act like a belt and pulley system in that we are getting the same direction of rotation inside of the belt, or inside of the chain in this case. So anything inside of the chain loop is going to have the same direction of travel. If it was on the outside, if I had a sprocket on the outside of that, the outside sprocket would turn the opposite direction. But in this case, anything inside is going to turn the same direction. Okay. So that is the sprocket and chain system kind of setup. And so what we'll be looking at is how do we use this information to find missing pieces. So if I was looking for what the output torque was and I knew the input torque, I can use this information either about the diameters or the number of teeth to help me figure out what that output torque should be given my input torque, or vice versa. Whatever that missing piece of information is, I can use a combination of 2 out of these 4 equations here to figure out that missing information. Okay. All right, so just kind of a quick comparison between them, between the difference between like a belt and a chain system. Like, why would you choose one versus the other? And there's definitely places where one is better than the other. Just within what we have at the academy, we have our drill press is actually a belt-driven system, which is kind of interesting, but it is. It takes from the motor and it uses actually a compound belt system. It's got two sets of belts to change the ratio, the speed and torque of the output. And you can kind of adjust that depending on what kind of material you're cutting. If I'm drilling something that's harder, maybe I need to go slower but have more torque, or maybe I need to, if I have a pretty light duty material, maybe I'm going to go fast and not as much torque. But it gives me the option to adjust it. So if you look in the top of the drill press, we actually have a belt system, which again, kind of interesting. Why would you want a belt system? Generally, it's quieter because it's not metal. It's a rubberized substance. It might have some like steel bands built into it just to make it stronger, but it's mostly rubber, and so it's going to be quieter. You don't have to keep it oiled up, so you don't have to lubricate it. Relatively cheap. Belts are a lot cheaper maybe than the equivalent amount of chain. Disadvantage for a pulley system is that it can slip. And if you've ever had a slipping belt on your car, it makes all kinds of crazy noises because it's just slipping and it's kind of creating high frequency noise. And where would that be a problem? Well, it's only going to be a problem if I really need precise rotation. I need both things to rotate at the exact same speed and always stay in the same orientation to each other, relatively. Then it's a problem. That's where if you are doing like a car, you don't really want a timing belt that has no teeth on it. Can you have teeth on the belt? You can, and that is something that we'll talk about later. But if you had like a traditional belt, like a V belt, where it doesn't have teeth on it, that is really bad for things that need to have very precise timing and keeping things, in an orientation to each other. Uh, they're not really good for that because they can slip. Now, if you don't care, like on my drill press, I don't really care if the thing slips a little bit every once in a while. In fact, I might actually want it to. If it's getting stuck, I might rather it slip and not turn than try to keep turning and break something. So sometimes that's an advantage, sometimes that's a disadvantage, but it is something that is true of a pulley system. Chain and sprocket systems are generally used when you need more strength. They don't slip, which is good because they have a nice positive lock between the sprocket and the chain. You've got, part of the sprocket's going into the chain and locking into it. So it is not going to slip. It's going to have greater strength to it. But the trade-off is it's a little bit more complicated. The chain itself is harder to build and harder to size. It costs more. It's metal, so it's got to be greased. If you don't keep it greased, it's going to get rusty and lock up, maybe, if you don't do a good maintenance on it. So it's got some good points and some bad points. We use chain on our first robot quite a bit for different reasons. Main thing being just because it is a fairly reliable way to provide power. And it is adjustable. That's one thing that is pretty nice about sprocket and chain systems. Chains are fairly adjustable. Now, there is some amount of tensioning that still has to happen. You can't just make it exactly the length that you want it always, but you have, depending on the size of your chain, the each link is going to be, something you can take off or add new links on if you need to. Belts you can also adjust. You have to cut them and then have a way to bind them back together, or you can buy belts that are the exact length you need, or you can design your system to fit a belt that already exists. You probably are going to need some tensioning there as well. So there's definitely some commonalities between those. Tensioning is a big thing for both systems. If your belt or your belt and pulley system or your chain and sprocket system is not properly tensioned, you will have problems. So both of those things have those issues. But either way, they both do well in those situations that they are best used for, and you just have to kind of decide: is your application going to be better for a belt and pulley system, or is it better for a chain and sprocket system? And that is it. We have finished up with that PowerPoint. And so we'll stop there, but you will want to follow up and do the practice problems. We'll have those available on Canvas, and then also you will have, I'll post a video kind of walking through those practice problems just so you know how to do them. But that's kind of what we're looking for. All right, thank you.